Okay, so today we will see further from where we stopped yesterday. Yesterday we had seen some of the basic definitions, uh, that is database, data, mini world. These are not so important exam point of view, but the next definition, mark it as important. I think last time, yesterday I have already dictated you this question. What is database management system? Or they will ask you what is DBMS. So whenever they ask you question about any abbreviation, first thing you will be writing is the full form. Database management system, correct full form you are supposed to write. It is a software package. Now, package ka meaning is it is a group of certain things, right? Package is a way of grouping, isn't it? So it is a software package, not like Java, but it is just in general terms, it's a software package to facilitate the creation and maintenance of a computerized database. So it is a specialized software package which helps us to create and maintain a computerized database. So this is a simple definition. And again, whenever they ask you the definition, always write even the example along with that. So which is a database management system? Yesterday I dictated you the examples. Can anyone tell me one of the example? Which is a DBMS software?
Oracle,
Oracle.
SQL,
MS
SQL
Excel.
Server,
SQL Server, MySQL,
MySQL, MS Access.
MS Access. And now, okay. So here you will be writing the example. Then what is a database system? System means again a group. DBMS software together with the data. So the software which works on the data is separate and the data is separate. The data itself is separate and the software which manipulates or processes that data is different, right? So together the DBMS software and the data together makes up a database system. And sometimes additional applications, again, we might have written some other additional code for the security or for some other use. So even that code together, it will make up a database system. Fine. Again, it's not that important exam point of view. So evolution of database, how it happened. Initially, people used to store the details in a flat file. Flat file means how you created last time Java's file or um, some paragraph in a essay kind of format. The flat files were created. But what was the limitation of a flat file? Searching for records was difficult. Data redundancy. Redundancy means repetition. Again, it is very important question asked frequently. So note down all of you. What is the next question? What is data redundancy? For 2 marks. So redundancy means repetition of data. And that repetition itself gives rise to inconsistency. Inconsistency means what? If I give you example, suppose your result is stored, or suppose your roll numbers are with every teacher. One teacher has got, suppose Mansi's roll number. I have as some, what's your roll number, Mansi?
416.
I couldn't hear actually.
Ma'am, it's 416.
416. Okay. Suppose if I store Mansi's roll number as 416, and then suppose some other faculty like whether Vaibhav sir, he might store her roll number as 460, 460. Then what will happen? The data is inconsistent. Inconsistent means consistency means uniformity or correctness or accuracy. When I say inconsistent means uh, now this inconsistency, now there is a confusion about Mansi's roll number. What is exactly Mansi's roll number? If it would be only one teacher or if it is stored at only one place, then there wouldn't be problem. This problem has occurred because it is stored at multiple places. So redundancy here, repetition of data storage has occurred. That's why inconsistency occurred. So that means redundancy causes inconsistency. Fine. Anyway, so in flat file system, same data was stored at multiple places, and that is nothing but data redundancy. And because of data redundancy, another problem was faced, that is called as data inconsistency. Now, why these points are important? Because even in Viva, or maybe even in explanation, they will ask you this question. Fine. What is inconsistency and what is redundancy? Anyway, these are the problems faced before the databases were evolved. Fine. Now, um later on, slowly after evolution, there was some concept of indexed file. This solved the problem to some extent, but again the problem was still there. And slowly from the indexed file, again the tables got evolved. Yesterday I already explained you about what is the structure of database. It is in the form of table, rows and columns. So this is how databases came into picture. Earlier the databases were manual, then the spreadsheets were evolved, and after that the modern computerized databases were evolved. Advantages of databases overcomes limitations of flat file. Then they are compact and easy to use. Now, how actually databases and DBMS looks. So here you can see normally whenever a diagram of databases is drawn, even in your project when you go to sixth semester, you will be representing databases like this in the form of a kind of cylinder. So can you see at the left side? A set of related records is normally called as database. Now database, uh, okay, and for a database to get stored in proper format, one kind of software is used which is called as DBMS. So DBMS is a computerized record keeping system which involves data, software as well as users. So let us see further. Now this database management system, again, fortunately those details are not there in your syllabus, but there were various models through which these databases were represented. The examples are network model, hierarchical model, etc. So through this model, the databases were evolved, and the latest and most frequently used model is RDBMS. Now what is RDBMS? What does R stand for? Can anyone tell? It is Relational Database Management System. What is it? Relational Database Management System. Everybody note the full form. Okay, Sanket Kulkarni, tell me what is the full form of RDBMS? 434, Sanket is here. Sanket, Shraddha Kumbar, 437.
Ma'am, relational database management system.
Is it Shraddha answering?
Yes, ma'am.
Okay, Relational Database Management System. Very good. So now let us see what do you mean by relational database management system. Fine. So here we have taken the example of college management system. When we think about college management software, again, remember a database is not a single table. Database is collection of many such tables. So which all tables will be used in our college management system? Again, it depends on the problem we are trying to solve. When we talk about college management system, again, a question arises whether we are managing employees or students. Again, when it comes to students, whether we are uh, considering admission and mark sheet both, or we are concentrating only on the examination pattern. So this is how, first of all, we should know exactly what we are solving through our application. So same thing, now your seniors are presenting their synopsis to us for their projects. So when this write synopsis, they should know exactly what they are solving. So for example, now the same, even you will be going through the same thing after 1 year. So you should know what kind of project you are doing and what problem you are solving through that project. Fine. Anyway, so here let us understand, in college management system, we are concentrating on students, not the faculty's salary, no timetable. Only we are concentrating on the management of the students. So in that, students' personal details is one file, then students' marks is another file, students' fee structure is another file. So can you see here right side, faculty salary details are not related. So this is how we will be restricting our problem, or we will be defining our problem properly. And unwanted things, we will first sort it out. We will just write them off. Clear? Okay, let's go ahead. So in relational, in RDBMS, what are the terms used? So RDBMS is evolved many years ago. And then when the RDBMS were evolved, they use their own sum of the terms, which are very, very important exam point of view also. So what are the terms they have used? Let's see. So here, as you know, that your database is made up of many tables. So example is students personal details table, students mark sheet table, etc. So the example here, what you are seeing is a table of some order details. Fine. So you have serial number, you have item code, then you have some order number, you have order date and product quantity, how many quantities of that particular item have been ordered. So this example is shown. Your database may be a collection of many such tables. Like now, each of this table is called relation. What is it called as? Relation. What is each table called as? Relation, remember. And again here relations are different and relationship is different. Fine? Clear? So each of them have got their own meaning. So here we are talking about relation. What is a relation? Another name for the table is relation. So in RDBMS or Relational Database Management System, every table is called as relation. Clear? Now, as you know that a relation or a table is made up of rows and columns. Which are the columns? The vertical sections are columns. How many columns can you see here now?
5.
5.
So 5 columns.
5.
Each column in DBMS is called as a tuple. What is it? Not tuple, sorry. It is called as an attribute. Columns are called as an attribute. So how many attributes are there in this relation now? 5 attributes.
5.
Okay. And the rows are called as tuples. So how many tuples are there in this relation right now? 5 tuples. So
5.
coincidentally, there are 5 tuples and 5 attributes. Clear? Yeah. So these 3 definitions we have seen. What are relation, what is tuple, and what is attribute. Okay. Now this relation itself is nothing but the table. What do actually tables store? Sometimes now in the database, there will be some user data in the sense there will be the data stored by the user. Then there will be a data about which all users are using this data. In the sense what? Yesterday I was giving you example. What is the advantage of database management system? That it gives you a security at different levels. In the sense, the same data may be accessed by different groups of people with different access permissions, different levels of access permission. Yesterday I gave you example of um, mark sheet, and then I told you student or attendance. Students are one level of users, teachers are another level of users, and HOD or admin are the third level of users. So when it comes to student, when students log in to see their attendance, they will be able to only see the attendance. Can they modify the attendance? No, they will be only able to see. When it comes to teachers login, teachers can modify the attendance, but of their own subject only and of their own students only. They can't modify any other students' data. Like I will be able to modify only 4B's DBMS marks or 4B's DBMS attendance. I can't say, okay, let me put it for 4A also. No, it is for different faculty, isn't it? So this is how at the teacher level I can modify my own division's attendance. When it comes to admin, they will be, or that person will be able to access everybody's, even the teacher's details he can modify. Anyway, so that is what is called as user data. User data in the sense, suppose if there is one particular table, and it is not that for every table there will be 3 levels of users like student, teachers, and admin. There could be multiple levels. There could be managers, then there could be low level managers, high level managers, etc. So how many levels of users you have created, all that will be stored in users data. Then there will be system data. System data means again, which is called as a metadata. So metadata stores additional informations about the data. That is called as metadata. Again, mark this as very important question. We will come to the definition later. Metadata. Fine. So whenever you create table, you define multiple things, like you define field names, which are called as attributes or the columns. Okay, let me write here using annotations. Okay, when it comes to a table, so what are these called as? What are they called as? Just now we saw in the previous slide.
Attribute.
Attributes.
Tuples.
No, not tuples. They are attributes. They are also called as what? Fields, or they are also called as columns. So columns, fields, and attributes, these are the, or you can say synonyms used for the same thing. Clear? Now, similarly, when it comes to horizontal sections, again, they are called as tuples. They are called as rows. Clear? Or sometimes they are also called as records. Now there is a pairing used. When you use the term attributes, you will be, along with that, you will be using the term tuples. When you use rows, we call the vertical sections as columns. And along with fields, we use the name records. Clear with that? Fields are the vertical sections, records are the horizontal section. Attributes are the vertical sections, tuples are the horizontal sections. Fine. Columns and rows, of course, I need not explain. Clear? So when you create tables, first of all, you will be defining field names, and then you will define data types. Then you will define field size, and then you will define constraint. So it is not that in a table, when you have to create table, you will be just I mean, you will go and start entering the details. No, first of all, you have to imagine. It is something like when the architect has to plan for a building, he has to first sketch certain things, like he has to put the calculation, how much is the space available, then what is the requirement, how many rooms, what kind of building we are going to build, how many rooms requirements is there, how much space has to be left outside the building. So with all these calculations, first of all, he will prepare some kind of design on paper. So similar to that design here, when we talk about table, here, first of all, you have to plan. What planning is required to create tables? Simple planning of how many fields we have to prepare, what will be the field names. Remember, field names have to be meaningful. You can't give any field names. Fine. Then data type means what kind of data you're going to store in those fields. Okay, let me give you an example. Suppose if I tell you to store um, students, okay, suppose if there is some competition, uh, okay, or if there is student best girl and best boy selection, and then Venugopal sir might have given you certain parameters like you have to write students' achievements, students' past score, then students' extracurricular activities, and then maybe if there is in-house and outside event participation, and then behavior in the class, attendance. With all these parameters, suppose you have to judge. Then these parameters, first of all, if suppose 20 students give their nominations, then you have to, suppose if you are told to store their details. First of all, what will you make? You will take the student and start writing essay for it. And suppose, for example, who is your senior? Suppose Rishikesh nominates for the best boy. Then, if Mansi is told to store the details of the students, will Mansi start writing essay about Rishikesh? Then the second person comes. Fine. Then again there will be a second essay written. Will you do like that, or what will you make? Yes, Mansi, how will you plan storing the details of the student? Did you understand the requirement?
Yes, ma'am.
So what will you do first?
I would create columns and rows according to the requirements and fill it with the name in one word.
Okay. What will you write in columns?
Eligibility, marks, code, everything in different columns, and then I would record it according to in front of the name. I would write it and record it according to it.
Yeah. So you're talking about details on the paper. Fine. When it comes to
Yes, ma'am.
computerized data, or when it comes to storing the same data in databases, what first of all you have to think is, of course, as you told, you have to first identify how many columns are required, how many parameters are told, and then uh, you have to think about the field names. Field names in the sense, here you will be writing
Yes, ma'am.
past score. Then here another field name will be in-house participation. Then another will be placement, and then another will be like that. You will be deciding the field names. Second thing, data type, in the sense every field's data will be of particular type. You know that when it comes to programming language, when you declare any variable, you have to also tell the compiler what kind of data is going to be stored in those variables, whether it's going to be a string data, whether it's going to be integer data, or whether it's going to be a floating point data, isn't it? So as you define field names, you have to also define their data types. So what will be the data type for name?
String.
String. When it comes to number of placements, what will be the data type used there?
Integer.
Integer, isn't it? When it comes to past score or average score of all the semesters,
Float.
Float.
isn't it? So for every field name, what kind of data is going to be stored, you have to also plan the data types. Then you have to plan the field size. Field size in the sense here, number of characters. Okay, so when you define the table, initially you should have planned how many characters are required to store the name. Fine. Then suppose if it is marks, how many maximum digits you will require for marks?
2.
3.
2, 3, depends on. If
3.
it is internal marks, 2. If it is final marks, maximum will be 3, isn't it? So it is like that. You have to decide the field size. Then fourth one, constraints. This word may be new to you, isn't it? Constraints means that comes only in database management system. That doesn't come in or any other programming language. So what are constraints? Constraints are the rules. So database management systems are such, you can say, um, modified softwares or such progress softwares that they allow you to define even your rules. Like for example, if you have to store marks, you can even tell database that I can set the rule that marks cannot be. It is something like that. Okay, let me type and show you. So if it is constraint for marks, you can write the constraints as marks should be greater than 0 and they should be, okay, marks should be greater than 0 wait, better write separately only. Marks should be greater than 0 and so and operator we use like this, isn't it? Less than or equal to 100. So that user doesn't enter negative marks, neither he enters more than 100. So this rule you can set. Even another example I'll give you. This is called as a constraint. Another example, if I have to store your date of birth, okay, date of birth of a student, can it be a future date? The person is yet to be born and his details are going to be stored in the database. Will it happen anytime?
No, ma'am.
No, it shouldn't, but it might happen when the user will do such mistake. See, as I told you last time, in case of exception handling, you have to assume that the user is going to be a dumb, a senseless person. In the sense, he may type any nonsense data, but it is a duty of a programmer to filter out such data. That means to invalidate. In the sense, you should validate the data, and invalid data you should not accept. Your program should not accept. But as a computer cannot think of its own, so it will accept any kind of nonsense data. So how will programmer put such rules? So that rules can be put through constraints. So database management system software allows you to define such constraint like date of birth should be greater than uh, should be less than today's date, something like that. So today's date is defined in the form of certain functions like today, something like that. Less than today in the sense it should be previous than today. It shouldn't be future date, something like that. Or you can put some other constraint that minimum age should be 20 years old, something like that. So constraints are nothing but the rules that can be defined at the time of data entry itself. Remember, after you enter the data and then if you try to define the constraints, then it may not be possible. DBMS will not allow you to do that. So that's why before you create the table, you should have planned the field names, you should have planned the data type, you should have planned the field size as well as the constraints. Clear with this? Yeah. Now example here which is given, example of a university database, and some of the tables in the university database could be students, Then the courses means it could be BBA, BCA or BCom. Then departments, and there could be instructors. Instructors means faculty. This is just an example given. Okay, we'll talk about these relationships later. Okay, now today we'll stop here. Tomorrow we'll discuss about main characteristics of database approach. So this is very important. 5 marks question frequently asked. Fine. Or we can cover one point here. Anyways. Otherwise, we'll cover it tomorrow itself. Fine. We'll stop here. All of you enter your roll numbers.